In linear SVM, the working of the SVM algorithm can be understood by using an example. Suppose we have a data set that has two tags, green and blue, and the data set has two features, x1 and x2. We want a classifier that can classify the pair x1, x2 of coordinates in either green or blue. Suppose consider the below image. So this picture is a 2D space. So by using a straight line, we can separate these two classes. But there can be multiple lines that can separate these classes. Consider the below image. The SVM algorithm helps to find the best line or decision boundary. This best boundary or region is called as hyperplane. SVM algorithm find the closest point of the lines from both the classes. These points are called support vectors. The distance between the vector and the hyperplane is called as margin. And the goal of SVM is maximize this margin. These points are called support vectors. The distance between the vector and the hyperplane is called margin. And the goal of the SVM is maximize the margin. This hyperplane with maximum margin is called optimal hyperplane. In this diagram, this blue line is separate dataset and this green line is separate dataset. So this particular line called support vector, and this particular gap from this line and this line called maximize, and gap between this line and this line called margin, and this line called optimal hyperplane, and this portion also called support vector. This portion also called support vector. For nonlinear SVM, if data is linearly arranged, then we can separate it by using a straight line. But for nonlinear data, we cannot draw a single straight line. Consider the below image. So to separate these data points, we need to add one more dimension. For linear data, we have used two-dimensional x and y. So for non-linear data, we will add a third dimension z. It can be calculated as z equal to x square plus y square. By adding the third dimension, the sample space will become as below image. Since we are in 3D space, hence it is looking like a plane parallel to the x-axis. If we convert it into 2D space with z equal to 1, then it will become as, hence we get a circumstance of radius 1 in case of non-linear data. Now we will implement the SVM algorithm using Python. Here we will use the same dataset user underscore data, which we have used in logistic regression and kernel classification. First we have to do data pre-processing step. Till the data pre-processing step, the code will remain the same. Below is the code.